Hello everyone, back tuning into the third update for winter of 2016-2017. So, we've done two updates so far. I think been quite interesting updates, and I hope you've enjoyed them. Running to about half an hour in length each one. Actually, the first update again on for 40 minutes. I'm going to try and keep this update to around half an hour if I can. So, we're going to pick up with the third update exactly where we left off with the second update. We're not going to be jumping around. We're going to carrying straight on from where we left off with the third update, looking at the analogues from our good friend James Ackrill in terms of ENSO. Last week, second update, we looked at the analogues for the El Nino to La Nina winters. We had the El Nino at the start of the year, so we're perhaps going into La Nina the end of the year, covering the winter period. So, last week we looked at the El Nino to La Nina analogues. This week we're going to look at the El Nino to neutral, ENSO neutral analogues, because more likely than not, it's actually that we're not going to have a La Nina, you're going to have a failed La Nina, and we'll just have ENSO neutral, albeit on the cooler side. So we're going to look at the ENSO neutral winters following El Nino for this particular update, amongst a lot of other things as well. We're going to look at solar activity, we're going to look at Siberian snow cover, we're going to look at what's going on in the tropical Atlantic in terms of storms and hurricanes. You name it, we're looking at it for the third update. So I've got a lot to cram in, and I'll get on with it in a second. Before I get on with that, just to say about the ads, there's links to articles on all of the pages. If you can have a browse widgets and click through links, you'll be helping us to pay for the website, and thanks very much for doing that. There's video ads on most pages which own that content. When you watch them, they close back up again. It does help to pay for gavsweathervids.com. Just to say that this update will be placed on the winter updates page later on today. You're probably watching this on the home page right now, but it will be placed on the winter updates page with the first and second update, and also the NAO forecast that we did back in the summer. And there'll be a written report to go with this video. So if you can't watch the video all in one go, don't worry, you'll be able to go back and watch it whenever you want on the winter updates page, or read the written report. And just say enjoy the video. It can be quite a long one, so you might need a comfy chair and a cup of tea and maybe a couple of biscuits. We'll be here for some time, but I'm going to try and keep it to 30 minutes or thereabouts if I can. Right, so as I said, we're going to pick up exactly where we left off last week. So last week we were looking at the El Nino to La Nina analogues, and in terms of the winters. And there's been a split with those analogues, actually. I think there's around 16 winters that have done the El Nino to La Nina flip. And out of those winters, something like 7 were westerly mild winters, and 9 were cold and more blocked type winters. And this goes right way back to the 1800s. So this is the combined chart that we were looking at last week for the 7 winters that do the westerly El Nino to La Nina flip. So these are all Atlantic driven type winters, and when you combine the 7, this is how it comes out, with high pressure to the south and tend to get low pressure to the north and bringing those westerly winds. And that's taking all the winters back to 1907 and up to 2008 that have the El Nino to La Nina flip going on. The winters that were, again, these are El Nino to La Nina flip winters, but these ones are blocked winters. They're colder winters, and there's 9 of these. So very slightly, it does favour, when you get a La Nina, an El Nino to La Nina flip, very slightly, it does favour a blocked winter 7 to 9. And when you combine all of those years, and these years go back to 1879 and all the way through 2011, you combine all of those winters, you tend to come out with blocking to the north and low pressure to the south, and the winds in from the east. Now, at the end of the video, I raised an interesting question, which is whether the more blocked winters, El Nino to La Nina winters, whether those were weaker La Ninas, and whether the more westerly, milder El Nino to La Nina winters, those 7, whether those were stronger La Ninas. Because my theory is that if you've got a weak ENSO event, either El Nino or La Nina, if it's weak, it tends to help or it doesn't hinder, perhaps it would be a better way of phrasing it, doesn't hinder getting blocking. Whereas if you've got a strong intervent, be it El Nino or La Nina, then it pretty much overrides any other signal, and the Atlantic just becomes like a steamroller and pushes through. So James went back and looked at these La Nina winters, El Nino to La Nina winters, and put them into weak, moderate, and strong categories. So what we can say is that we can only go back to 1950, unfortunately, with these. We can't look at the winters that were in the analogues package going back into the 1800s. But I think it does prove the point, actually, this. So in the weak column here, these are all weak La Nina winters. And the ones we're specifically interested in, of course, not just the La Ninas on their own, but the La Ninas that are doing the El Nino to La Nina flip. So they had an El Nino in the winter that preceded them, if you see what I mean. And out of the two winters in the weak column that did that, in the weak La Nina column, both of those are cold winters, 1954-55 and 1964-65. In the moderate column, so that's the weak column, weak La Nina. In the moderate La Nina column, again, during the El Nino to La Nina flip, we find 1970, 1971, and 2010, 2011, moderate El Nino to La Nina winters, and those are cold winters, particularly focused on December, interestingly. December 1970 was cold, less so for January, February 1971, and of course we know December 2010 was the December to remember, and then it turned milder in January and February 2011. So interestingly, although 2010 was much, much more severe than 1970, interestingly they both have cold Decembers, those two moderate El Nino to La Nina winters. However, there are two milder winters in there as well, with 98-99 and also 2007-2008. So it looks like in the weak column, it's a pretty strong signal when you're going from El Nino to La Nina to get a colder type winter, albeit there's only two of them. In the moderate column, it's split evenly. There's an equal chance, by the look of it, between having a mild or a cold winter when we do this El Nino to La Nina flip, have a moderate La Nina. Now in the strong column, it's very clear, look at this, that it's just mild. 1973, 1974 was a strong La Nina, and that was, of course, a mild winter. 1988, 1989, also a strong La Nina and a very mild winter. Interestingly, both of those winters are quite dry winters as well, I think. And also, although it wasn't an El Nino to La Nina winter, it's just a straightforward La Nina winter. It's actually a second La Nina winter, 75-76. We find that one, strong La Nina, also coming out mild. Come back to this weak column, interestingly, again, because let's take away the caveat it's got to be an El Nino to La Nina. Let's just think about a weak La Nina. And it's striking how many of these winters are coming out cold. We've got 1950, 1951, which was a cold winter, particularly in December. We've already looked at 54, 55 and 64, 65. That was a cold winter as well. We've got 84, 85 here, a cold winter. 95, 96 is a cold, weak La Nina. 2000, 2001, although it wasn't that cold, was one of the colder winters between that period from, let's say, 1991 to 2008. There was hardly any cold winters, but 2000, 2001 was one of the colder winters that we had at that time, along with 95, 96, 84, 85 we've already spoken about. 67, 68 also was a fairly cool winter, especially in January 1968. These other winters here are generally a bit milder, so it's not a guarantee of anything, but I think quite obviously a weak La Nina does very often go along with a colder type winter, whether it's an El Nino to La Nina flip, or whether actually no, it's just a straightforward La Nina, say following on from a La Nina before. Sometimes you get 2, even 3 winters, but a La Nina winters in succession. And if they're weak, I think we demonstrate here that very often they tend to be quite cold. Also over here in the moderate category, we've got 55, 56, again, quite a cold La Nina winter. So I think that quite clearly demonstrates what we was talking about last week, in that the key, either with El Nino or with La Nina, is to get them to be weak if you want colder conditions. Well, this week we're going to look at ENSO neutral. So this was the situation in terms of the sea surface temperature anomalies last week. 3 areas we're looking at, of course. We've got the Atlantic over here, we've got the Northern Pacific up here, and then we've got the Tropical Pacific where we get the ENSO events going on just there. That was the situation this time last week. Going forward to this week, we can see that there's been very little change really in the Atlantic, so I won't dwell on that. This colder area here in the central Northern Atlantic might be getting a little bit bigger again, if anything, but overall the Atlantic is still quite a lot warmer than it has been for the last couple of winters. Still very warm in the northern part of the Pacific Ocean. That's showing no signs of abating. And then we come down to the equatorial Pacific Ocean. Been very little development with La Nina. Maybe slight cooling has taken place over the week, but really, I think it's scraping the barrel. We are still more or less ENSO neutral, just about borderlining on a weak La Nina. As I say, the modelling, I explained this last week, the modelling is generally in favour of ENSO neutral. So let's have a look at the analogues for these ENSO neutral winters. James has put them all together. There are many of them for us to be going at, actually, with these El Nino to ENSO neutral type winters. There's a lot of them to be looking at. In fact, there's something like 16 of these winters to be going at, right way back. The earliest one in the analogues package is 1867, and then we go right the way down to the most recent one, which was 2006, 2005, 2006. Now we combine all of those 16 years. This is what you tend to come out with in terms of the reanalysis for all of those 16 winters. So you tend to get a ridge in the Atlantic and extending up towards the south of Greenland, and then you tend to get a trough of low pressure extending down to the north. So essentially the jet stream is doing something a little bit like that. Almost places us on the cool side of the jet, but it is reasonably Atlantic driven with the air coming in that direction. So maybe coolish and similar perhaps in some ways to the La Nina winters. We do tend to get this ridge in the central part of the Atlantic, which of course is tending to block off the Atlantic. So not particularly wet winters following an El Nino. I would assume very often these winters can be dry. So let's have a look at them on an individual basis. We start with 1867. And this one looks straightforwardly Atlantic driven. Look at that, maybe back in middle of the 1800s, but even then, fair share of mild winters going on, and this one's straightforward westerly, southwesterly Atlantic driven winter. The next one is 1898, and again that one shows a ridge down to the south with low pressure up to the north, and the jet stream coming through rather like that. The next one is 1913. Looks a very wet winter. This one, deep trough of low pressure in the Atlantic, a ridge through Central Europe, and the jet stream coming through rather like that. So I would have thought that's fairly mild, but the main thing probably is that it's exceptionally wet, especially in the west. 1916 is our next winter, 1915, 1916. That's a very interesting winter. I may do a historic video about that one day. The mean anomaly is for trough of low pressure be to the north, but there's a lot of intra-month variation with this winter. There was an exceptionally mild January. It still holds the all-time January CET record, but there was a fair share of cold weather as well at times through 1916. So as I say, one day I might do a historic video on that one. 1920 is our next year. At the moment, they're all looking pretty mild, aren't they? We've got low pressure up to the north, high pressure down to the south, and just again straight for westerly, mild Atlantic-driven winter. 1927, maybe a little bit different with this one. More of a ridge out to the west, which means that the flow is going something like that. So that's a slightly cooler winter. I don't think it's particularly cold. There were very few cold winters in the 1920s, 1930s, but it's a little bit drier, if anything, I would have thought, and just generally fairly nondescript type weather. Our next one is 1932. This one looks very dry, a big ridge sitting right over the top of the country, low pressure well out in the Atlantic and to the north and the east, with the jet stream going rather like that. That would have been a very dry winter in 1932. 1953 is the next one, and we've got a ridge out to the west. So these winters through the middle part of the 20th century, they're changing compared to what you had in the 1800s and the early part of the 20th century, where they're generally very westerly. Now we've got a lot of ridging out to the west, and again, similar to 1927 in a lot of ways, the flow is going rather like that. So again, quite a dryish winter, fairly nondescript, not particularly cold in 1953. 1960, very interesting winter this one. Lots of northern blocking to the north of us, but we place this very deep trough of low pressure through the Atlantic and into the UK. That's nearly a really cold winter, but actually the winter of 59-60 was generally quite a mild one, and also very wet at times as well. The next year is 1967, so this is winter of 66-67. This was one of the milder winters of the 1960s. Low pressure going through something like that, a ridge up to the north. Still hints of a little bit of northern blocking. It's an odd looking chart really, but the flow's going a bit like that around the trough. Again, 66-67 was one of the milder winters of the 1960s, but a lot of cold winters in the 1960s. Now our next one, this is a bit more exciting, not been much for cold lovers to get their teeth into, but our next winter, that goes from an El Nino to ENSO neutral. Look at this, it's 1979. That's picked your ears up, hasn't it? We've got all of this blocking up to the north through the winter of 78, 79, and then a southerly tracking jet stream. Look at that beautiful southerly tracking jet stream with really cold air being entrenched into that trough from the north and the east. That's the first one that's really had anything interesting, I think, for cold lovers. The next one is 1981. So this is December 80 to February 1981. Again, very similar. It's a trend here, isn't there? With a lot of these years, high pressure out to the west, low pressure up to the north, the flow from a northwesterly direction. So they're not cold winters, but they're not exceptionally mild winters either. They're quite cool winters, but with very little weather going on. Just cool, nondescript type winters, really, with high pressure centred more or less to the west. 1984 is next, winter of 83-84, going from the Super Nino of 1983 through to the ENSO neutral condition of winter of 83-84. That's an odd winter. What happens is that we have a ridge around the Azores, so you would expect to be quite mild, but there's also a lot of northwesterly influences, and those northwesterly winds are dragging cold air out of Canada and Greenland right away through the Atlantic into the UK. So it was very cool actually in the latter stages of that winter of 1984, Atlantic driven, but a lot of cold zonality. 1993 is next. This one doesn't stand out in the memory at all. Lots of high pressure around the UK. It's another mild 1990s winter, the jet stream going somewhere up here. Another one of those mild 1990s winters. 2004 is our penultimate year, and that one a little bit more interesting in the winter of 2003-2004, in that we get high pressure to the south of Greenland, which almost gives us a cold winter. It started off fairly mild, but by the time we got through to February, it did turn colder after an exceptionally mild start to February 2004. And our last winter is 2006, and this one is a bit more interesting as well. Has low pressure to the south, high pressure centered over Scandinavia. It was very close to being a really cold winter, this, but it just didn't align quite right until late on. It did get quite cold in the end of that winter, but somehow or other we didn't have a particularly cold winter in 05-06, but it was one of the cooler winters of the early and middle 2000s. So when you combine all of these years, the years that come out westerly, how many of them are there? There's 1, 2, 3, 4, 5, 6, 7, 8 of these winters come out westerly, and they tend to have a ridge down to the south with low pressure up to the north and the jet stream coming through. The winters that tend to have more block conditions, and remember, it's not ideal for blocking in a lot of these winters. Very often the high pressure centred to our west and not doing anything particularly cold. 1 or 2, particularly with the focus on 1979, do get quite exciting, but those years are in the minority. But there's 1, 2, 3, 4, 5, 6, 7, and 8 again that have more sort of anticyclonic influences, and they tend to have a ridge somewhere to our west and low pressure to the south. So it's a 50-50 split really when you've got ENSO neutral after an El Nino, between whether you get a lot of high pressure or a lot of whether you get a lot of high pressure dry weather or whether you get a really Atlantic driven. I think there's more interesting winters in the package, the analogs package, for the weak La Nina winters compared to the ENSO neutral winters. I'm not quite sure why that should be, but out of all of these years we just looked at, it's only really 1979 that is actually exciting from a cold perspective. Some of the other years, 2006 for example, do have a little bit of interest, but only one year really in that analogs package that we just looked at is quite exciting. Whereas last week there were several of those, several of the years were really interesting years from a cold perspective. So that's how the analogues are looking. Weak La Nina looks like it's what you want if you want a cold winter. If you're going to be ENSO neutral, there is the chance of some colder weather, but it's not quite as straightforward as if we get weak La Nina. We'll continue to monitor La Nina and see how things develop in the Pacific Ocean. And this is the SOI, the Southern Oscillation Index. It's beginning to go quite strongly positive. These are the numbers from the 1st of September up here when it was plus 8.2. The SOI, Southern Oscillation Index, is an index that reflects the state of the atmosphere in the Southern Ocean between Darwin and Tahiti. When it's very positive, it's telling you about the atmosphere is in a La Nina state. When it's very negative, it's in an El Nino state. What's been going on over the past few months is that we've been trading positive and negative SOI numbers, so it's not really allowed, the atmosphere hasn't really allowed the La Nina to develop. But we are going more positive, interestingly, with the SOI now. So if we come down to, say, the 6th and 7th of September, those were very weakly negative, still a little bit reflective of El Nino. But if we scroll further down, we have had some very positive numbers just recently, plus 10, plus 13, plus 12, plus 18. On the 13th, we went to plus 30. The 14th September went to plus 27, 15th plus 20, and then 16th plus 15. Those are the kind of numbers we want to be seeing to get a La Nina in place. Now, it's too late in the year to get a strong La Nina going. But to get a weak La Nina, and from a cold perspective, a weak La Nina is what we're looking for in some ways. To get a weak La Nina, we want to see consistent positive numbers of the SOI. And it looks like it is shifting more towards the positive side of things, actually. So that's going to be one to keep an eye on over the next few weeks. If we keep that positivity going of the SOI, we may start to see those sea surface temperature anomalies becoming colder. Right then, been going on for quite some time, so it's 24 minutes. Going to try and whiz through the rest of the update for you. We're going to look at something completely different now. We're going to look at hurricane activity, storm activity in the tropical Atlantic. This is the latest in terms of the 2016 hurricane season. We've had 12 depressions, 11 total storms, 4 hurricanes, and 1 major hurricane, that's category 3 or above. So things have moved a little bit compared to last week. I think last week's numbers, it was something like 9 for total depressions and 8 for total storms. The hurricanes and major hurricane numbers haven't moved yet, but it looks like things are beginning to develop in the tropics. We'll keep an eye on that. Remember, if you get a lot of hurricanes dumping a lot of heat in the tropical Atlantic, it can translate back in the winter to an increased risk of blocking. QBO, don't want to dwell on this too much, but we know we're in this very unusual state at the moment. We should be in an easterly QBO, looking a bit like that and a bit like that. Instead, what we've got is this very odd looking situation where we're not really neither westerly or easterly. This is the easterly QBO just here, but we've got a lot of westerly influences above. I am hearing that some of the forecasters at UK Met Office are beginning to suspect we will have an easterly QBO in place by the winter. So we're going to look at this more in subsequent updates. Easterly QBOs mean that the zonal westerlies are weakened. So easy QBOs at their very crudest go with more of a chance of blocking and colder winds, but not nowhere near as straightforward as that. But the folks at the UK Met, I think 1 or 2 of them are suspecting we could be in an easterly QBO by the time we get through to the winter. We'll continue to monitor that and talk more about it later on in the updates. Siberian snow cover yet. Next, not much going on over Siberia. We have had a little bit of snow beginning to appear in the far eastern corner of the Siberian plain, but nothing definitive. But it's early days. It'll be in October that this becomes much more important, when all of this area will fill up with snow. How quickly it happens will be interesting to see through October. It happens very quickly. It can sometimes, not always, can sometimes go along with an increased chance of a colder winter. Maybe a little bit delayed on where you'd expect us to be by this point in September. You might expect a little bit more of this to be filled up with snow by now. But it's really early days, and it'll actually be the next update, which will be the first sunny in October, the 4th update, when we'll begin to look at this much more and start to compare back to previous years. In terms of what's happening with Arctic sea ice, that's the ice we've got left, the yellow area. The blue area is where the ice has melted and opened out into open water. It's been another really big melt season this year, and in fact we have reached our minimum, I think. So this I've been showing this over the past couple of updates. This is the Arctic melt season for 2016. This red line just here, you can see downhill all the way. There's the date. So from around April, May, been downhill all the way. But look at this, right at the very end, we're just starting to tick up ever so slightly. And we have not reached the death spiral year of 2012. That's this green dash line just here. That was the worst year in the record for how much ice we lost. Let's see which years we are closest to, back to 2006. I'll start to fill them in. There we go. 2006 was a good year in terms of retaining sea ice, almost up near the average up there. 2007, this blue line, look at that. That was a crash year. Bit of a disaster for sea ice at that point. Of course, 2012 was worse, but 2007, that was a real shocker when that came off. And we are on a par with 2007. So obviously, it's been another big melt season. 2008, yeah, that's similar to where we are. 2009 was a little bit better. 2010, a little bit worse. 2011, very close to where we are now. 2013, very close. 2014, that was a better year, closer towards 2006. And then finally, that brings us up to 2015. And again, very close to 2015. So what's actually happened this year with the amount of ice we've lost is that we are very close to many of the years since 2007. Now, 2007, when we lost this much ice for the first year ever, it was a huge shock, and it sent shockwaves across the climate and weather community. Because 2012 was a lot worse, even worse, actually now we're a little bit blasé about these years that are on a par with 2007. We have several of them. This year is another one. We're a little bit blasé about them now, but before 2007, if you would have had an ice melt season like this, it would have been a tremendous shock. It would have sent shockwaves through the community, but because, as I say, 2012 was a lot worse, we don't get that concerned about it. But it has been another big melt season in terms of the Arctic, and the idea behind this is that if you lose a lot of ice in the North Pole, that can translate back to an increased risk of blocking. Although it's quite controversial, fairly new idea. It's only been in play really since 2007 and the run of cold winters that we had at the end of the 2000s, so 08, 09, 09, 10, for example. Those cold winters, there was a bit of an idea at play, but maybe some of that could have been related to what happened in 2007. Then we had that big melt season in 2012, and we know that was followed by a colder winter in 2012, 2013, and that's severe and blocked March. So the idea is there, but it's quite a new idea. There's not a lot of evidence for it, but I like to throw it into the mix anyway. So we're done, I think, with that now. We should continue to see Arctic sea ice trending up. The refreeze should gather pace over the next week or two, and things should improve very rapidly now in terms of Arctic sea ice in the North Pole. Of course, the damage has been done for this season for the ice we lost. Finally, let's have a look at solar activity. This is the solar disk on our side of the disk today from solarham.net. Solar activity is officially very low, at very low levels. We've just got this one area of sunspots just here. They're very weak sunspots, not doing a great deal, and Solarham has designated today's activity as very low. In terms of our tracker, this is new for GasWeather. We're going to be looking at this every week from now through to the end of the winter updates. This is the GasWeather's Winter Update Daily Solar Tracker, updated to the 17th of September. Our good friend James Ackrill has sent this over for me. He's monitoring sunspot numbers on a day-by-day basis. We can go back to June, when we see we did have quite a dip in activity through June, several completely spotless days in June. Then we had quite a big increase in solar activity, sunspot numbers, into July. Then it went a bit quieter again at the end of July, so it's been up and down at the moment. But the latest is that we are trending back down again. You can see that all of the lines, the red lines, the green line, and these lines up here, they're all beginning to show a bit of a dip downwards. It looks like we're beginning to see solar activity weakening. This is where we are at the very latest, to the 17th of September, going down almost towards no activity, but still just a little bit of sunspot activity taking place. We'll monitor this every week right the way through to the end of the updates. It'll be interesting to see whether these lines continue to flatline, or whether they move upwards, or indeed whether they do something like that and go back to where we are, or where we were just there. Remember, weak solar activity goes along with an increased risk of blocking. So when we're in solar minimum, particularly, and just coming out of solar minimum, 2 or 3 years after solar minimum, that tends to be our greatest chance of getting colder, blocked type winters. But reasons aren't all that well understood. But we know that weak, low solar activity for the UK and Europe, anyway, tends to go along with an increased chance of blocking. And on the next winter update, which will be the first Sunday in October, the 4th winter 16-17 update, that one is going to look more in depth at solar activity, and we're going to go back to the solar cycle 12, a 24 connection, and have a look at the winter of 1887, I think it is. So that'll be coming up in the 4th update, which will be the first Sunday of October, because next Sunday what we're going to be doing is the first seasonal model roundup for winter of 2016-2017. I've gone on for quite a bit longer than I anticipated. Again, sorry about that. So for next week's update, it's the seasonal models. We're going to get them all together for the first time this season. Have the CFSV2, have the Beijing Climate Centre, have the UK Met Office, have JAMSTEC, all of your favourites. They'll be included in the mix next week, and a new one as well. I'm quite interested to show you. So that'll be next week, and all models together. And we'll have a look and see what the consensus is for the first time this season for winter of 2016-2017. The tracker, by the way, will do a blog post about that on the blog next Sunday, so we won't miss out on the latest from the GABS weather viz solar activity tracker. Right, that's it for the 3rd update. Hope you enjoyed it. It's gone on a bit longer than anticipated. Again, sorry about that. We're 5 minutes over the runtime that I set myself. This is going to be placed on the winter updates page later on today. There'll be a written report that goes with this, just explaining everything in a written form, what we've discussed in this 3rd update. And that's all for now. I'll come back next week for the seasonal models. That's all for now. Thanks for watching.